going to do section lesson 10. We are going to read the situation. We're going to determine a domain and a range. We're going to determine numbers that could go into the situation and numbers that could come out of the situation. And you're going to take a moment and try this on your own first. So the first question says, a professional basketball player earns $150,000 for each game played, and there are 82 games in the season. So when we talk about domain, we want to talk about what needs to happen first to get the result. In this case, what needs to happen first? Does money happen first, or do games played happen first? What happens first? The number of games you play is going to determine the money that you get. So our domain is going to be the number of games that we play, or the number of games this player plays. Let me write that as a real word. Number of games played. And that means our range is going to be the amount of money earned. Amount of money earned. So now when we talk about domain, we want to talk about the lowest number through the highest number possible. So I wrote in words what the domain and range are talking about. You guys are going to tell me numbers. I need to know the lowest number and the highest number of games played. Because this is a situation where the player hasn't played anything yet. What could happen? Could the player play every single game? Well, what also could happen to the player? What happens in sports sometimes, unfortunately? You get an injury. What if the injury happens before we even play a game? Or you could get suspended for doing inappropriate things. Yeah? So what is the lowest amount of games that this player could play? What's the lowest amount? 0. So I'm going to say my domain is between 0, oops, that was not supposed to be that color. Gonna make it match. It's gonna be from 0, and I'm gonna just use X as a variable. What is the highest amount of games that this basketball player could play? Sophie, what's the highest number of games? A little bit louder, hon. 82, good. So that's the domain. Anything between 0 to 82, including 0 and 82, that's the domain for this situation. Now we're going to find the range. So let's look at our domain. The domain determines the range. So if we play 0 games, Ella, how much money will the basketball player earn? $0. So the lowest amount that this player could earn is $0. And this is our range, so this is our Y values. What is the highest amount of money that this player could earn? The highest amount of money that this player could earn. Emma. So it says $150,000 for each game played. So $150,000 would be one game. When you're pulling your calculator, tell me what you're doing on your calculator. We're going to do whatever 150,000 times 82 is. And I'll go ahead and find that answer and write it down here also. But that's what we're going to do for that number. If they played every single game, 150,000 times 82. And I'll just copy it down from my calculator. 1, 2, 3, 0, 0, 0, 0, 0. $12 million. Sounds about right, huh? All right. So the next one, you eat up to 5 meals a day with an average of 844 milligrams of potassium at each meal. So you, on your own, I want you to take a moment to see if you can figure out the domain and the range. Again, the domain is the thing that has to happen first. The domain determines the range. Jaden, do you know what word-wise, in words, what the domain is? Number of meals. Yep. Oops. Okay, and that leaves the range for Brooke. So I'm not going to use the number at all. I'm just going to say like the milligrams of potassium. How do you write milligrams? Like the shortened version of it? Does anybody know that one? But isn't that milliliters? That's milliliters. I don't know how to write milligrams. I just write the word out. By now I could have written it out, right? mg? I think you're right. I think it is mg. mg. There we go. All right, so number-wise, Grace, can you help me with the domain numbers? What's the lowest amount of meals?
0.
And what's the highest number of meals?
5.
Good. So we'll just write 0 less than equal to x less than equal to 5. There's our domain. And Jackson, can you help me with the milligrams potassium?
0 less than equal to x less than equal to 844.
Hold on 1 second. It's not going to be x. It'll be y because it's the output. And then 844 by itself is not the final answer. So 844 is per meal. But over here we know we could eat up to 5. You need to multiply it by 5, right? So whatever that is, take out my calculator. I mean, I could do it by hand, but we are in high school now. If we don't know how to multiply by hand, we got other problems to deal with, right? Right, okay. All right, the average amount of money spent on food per person at an amusement park can accommodate 2,500 people is $5.25. $5.25. That's the average amount of money spent on food per person that can accommodate 2,500 people. So we have to figure out what is the input to the situation, what is the output. What do we have to know first that determines the other factor? Tessa, can you help me out with the domain, please?
Is it how many people are there?
Mm-hmm. The number of people. And let's go ahead and do the number of people, the math part of the domain. And Nina, I'm going to ask you to help me with the numbers for the domain. Very good. And then range. We need to know what the range is going to be, like in words, what the range will be. Ryan, what's the range?
How much does food cost?
It's not how much the food costs. Maybe you mean something but said it a way that I didn't understand, because it costs $5.25.
How much is spent?
How much is spent, right. How much money spent on food? And then to write that inequality. Macy, can you help me with the inequality? Oh, I didn't hear what you said after 0, sorry. Oh, less than equal to. Try it, less than equal to. Okay. So 525 would mean we only had one person, but our domain says could be 2,500 people. You need to take 525, multiply it by 2,500. Whatever that is. So $13,125. So that wasn't too bad, reading words and giving words back. It wasn't too bad, right? Okay, let's add on more. Now, we have already studied this. You just had a quiz on it. Us, I think, did not study very well because some of us, I already know, forgot that. So just a reminder, when we have a point and we have the slope, you can find the equation of the line using point-slope formula. We do y minus y1 equals m multiplied by x minus x1. You plug in the ordered pair, the point, whatever x1, y1 is, you plug that in, and you plug in the slope, whatever the m value is. That's my slope. And then you have the equation in point-slope form. And then from there, you can change it into whatever form you need. Also, it's not written here because we should know it, but for the formula for the slope, finding the slope formula, that is y2 minus y1 over x2 minus x1. How can you get those memorized? Write them down. Like when you do your assignment, write the formula before you plug those numbers in. That's how you're going to get it memorized. And if that's not enough, then make flashcards or something. Write it 100 times. So we are going to interpret this model. We're going to interpret it and write an equation, a math equation that goes along with this model. And this is what people do in real life to predict data, to guide astronauts into space. People take information and put math to it. They model it. So here, a graph shows the distance an asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. So when I say the words interpret the slope, That means write the meaning. Now that does not look like the word meaning. I'm going to fix my handwriting. Write the meaning in words. That's what that means. Write the meaning in words. That's what interpret means. All right, so we want to find the equation of a line. We're going to start with point slope form. Y minus y1 equals x times. Oh, that's not an x. Undo. There we go. M times x minus x1. Okay. Point slope formula. In order to do point slope formula, we need a point and we need the slope. Have they given us any information? Warren, have they given us any information? A point. Which point did they give us? So we look at the graph, and there's our x1 and our y1. So I can plug that in just a moment. Did they give us the slope? Ariana, did they give us the slope? We can find the slope. They didn't give it to us, but we can find it. You're right. Now, we can count on the graph, rise over run, or we can use the formula. Either is totally fine. What you would need, though, is you need an ordered pair. And I'm going to look for the easiest possible ordered pair, and there's an ordered pair there at 0, 0. Oof. By the way, before I go and find the slope, what is actually happening in this situation? We have an asteroid. You guys know what an asteroid is? Asteroid. So we've got this big ball of, what is it, like space rock? Is that what an asteroid is? Here's my space rock. Big ball of space rock. Please don't be jealous because I am like a really talented artist. That might be a little joke. It's okay to laugh at me. Here's my big ball of space rock, okay? And then that, it's in the sky and it's like flying through the sky, right? Okay, so what does the time tell us? What's time telling us? Like, what's this? Jacob, do you have a clue? Do you have a clue?
How far it's going in 100 seconds.
Okay, so you're talking about both, so I'm just talking about time right now. So yeah, it does have to do with how far the what is it called? Asteroid is traveling. The number of seconds that it has traveled would be our x values, the number of seconds. That's our time. And then the distance would be how far it is traveling. So when we find our slope, you could do 24 minus 0 over 5 minus 0, or you could just count rise over run, 24 over 5. And that doesn't reduce, right? Doesn't reduce? Okay, so let's go ahead and write our equation. We've got y minus, our y1 is 24, equals 24 fifths times x minus x1, which is 5. So now I'm going to change this equation into y equals mx plus b, so I'm going to simplify it and solve for y. Y minus 24 equals 24 fifths x. And when I multiply 24 over 5 multiplied by 5 over 1, do you guys know what happens to the 5s? Does anybody know what happens to the 5s right here? Yell it out. Help me out. What happens to my 5s? Nobody knows? They cancel because you're multiplying by 5, and then we're dividing that by 5. So these are inverse operations. They cancel. So I just get 24. And I'm going to add 24 to both sides. Oh. And so we just get 24/5 x. So that is the equation that shows how far a comet has traveled in amount of time. So now we're going to interpret our slope. Interpret. Now when we interpret our slope, I'm going to ask us to take 24 over 5, the slope, and we're going to actually divide it. So I'm going to use my calculator if I need it. I'm going to take 24 divided by 5, and I'm going to get 4.8. So I'm going to get 4.8. The reason why I divided that is so that the bottom will be 1. The reason why I divided it is so to make the bottom 1. That's why I divided it, so that the bottom number would be 1. So we are going to interpret this. We're going to look at the picture. And we're going to look at what x represents. And we're going to look at what y represents. And in the picture, what does x represent? Already talked about this. What does x represent in the picture? Sierra, what's x represent?
The second.
Mm-hmm. So I'm going to have on top, I've got 4.8. On the bottom, I've got 1 second. I'm just going to write seconds instead of seconds. And then, so what does the top number represent in the picture? What does the top number, Brene, what does the top number represent in the picture over here? Miles. And you know what? It's distance in miles, so I'm just going to write distance. Or you can write how many miles. Yeah, let's write how many miles. That sounds better. So now I'm going to write out a statement, but I want it to like actually make sense, like a complete statement. So the slope is going to be interpreted as this asteroid travels 4.8 miles per second. If you don't know, this division bar a lot of times will mean per when we're talking about rates. When we talk about things like miles per hour, that has to do with the division. So this is interpreting the slope. The asteroid travels 4.8 miles per second. Okay? And then the asteroid came within 17,200 miles of Earth in February 2013. About how long does it take the asteroid to travel that distance? So say that asteroid was coming straight at us. And in February 2013, it was 17,200 miles away. How much warning would you need to get out of the way of the asteroid? How long will it take for that asteroid to crash into Earth if it's coming straight to Earth? How are we going to find that out?
I want to know when you
Me
find
too.
it out.
Yeah.
Yeah, I was very excited about that.
It's 2013, so I don't think it hit, but I don't think it did.
No, I don't think it did, but yeah.
So how can we find that? We're given the amount of miles. We need to know the time. How can we find that? Amar, do you have an idea?
Would you divide 17,200 by 4.8?
I will end up doing that, but you know how I'm going to do it? I'm going to use the equation that is given to us, that we figured out, y equals 24 over 5x. And I'm going to plug in the distance, 17,200 miles equals 24 over 5x. Now, that is the same thing as 4.8, so if you'd like to write 17,200 equals 4.8x, that would be the exact same equation. And then to solve it, yeah, we're going to just divide 4.8 both sides. And I'm going to go ahead and use my calculator. And I get this number. What is the unit on this number? What's this unit represent? The number represents 3,583.33 what? Amar. Seconds. All right, you guys, you've got 3,583 seconds before this asteroid hits. Do you have a concept of how long that really is? So let's put it into a time that makes sense to us. Like 3 seconds I could understand, but 3,800, 580, whatever it is, I don't really understand that concept of time. What could we do to find a time that we understand better? Yes, Jackson?
Could you take that and divide it by 60?
And why are you dividing by 60?
Because a minute is 60 seconds.
So now I'm going to write it a little bit slightly different, but 1 minute per 60 seconds, that is dividing by 6. Yeah, that is dividing by 60. I'm just setting it up in a way that my seconds cancel. You may have done this in a previous course, but yes, that's exactly what we're doing. We're taking that answer, we're dividing it by 60. And I get 59.722, approximately 722 minutes. So if you knew that an asteroid was 17,200 miles away from Earth, you think you'd be able to get out of the way in 59 minutes? Almost 60 minutes, even an hour. That's pretty scary, huh? I mean, that's one reason why people go and study space, so that doesn't happen to us. They study those far objects that are moving around, make sure that we have more than an hour to find out that it's about to hit the Earth. Armageddon style, right? You guys seen that old movie? Oh, it's a good one. You should totally watch it. Have you seen it? Armageddon? It's a good one. All right, now it's a student practice. Let's see if we can do it again. For a moment, because I'm going to have you look through your work, see if you can figure out some of the stuff that we did, and then of course I will go over it as a group. But I'm going to pause the video while you try to do some of it on your own. I'm a teeny bit worried my video is not working because for some reason my hand is paused there. But it's not. If it doesn't work, I'll just have to record one after school. All right. So now we're looking at this car loan. And what's happening is we're making payments on a car loan. Well, what happens to your car loan as you make payments is the amount you owe goes less and less. It's going down. So we use our slope formula, or we can use the graph, but the graph's a little bit harder to do in this case because the units aren't evenly spaced. So I'm just going to use the slope formula, which is y2 minus y1 over x2 minus x1. That's my slope formula. I write it over and over again so I know it. So in this case, my y2 is going to be 15 minus my y1 is 18 over my x2 is 10 minus my x1 is 0. Now some of you did 18 minus 15, and then you could do 0 minus 10. Either way, we're going to get the same answer. I'm going to get negative 3/10. So we're going to put that into an equation. We're going to use point slope form, and until you have that memorized, you keep writing y minus y1 equals m times x minus x1. That's how we memorize things. So I'm going to plug in the stuff I know. Y minus. Now, what ordered pair should I use? There isn't a right answer, but what ordered pair should I use? One of them's easier. What ordered pair should I use? Jaden, do you know? The 0, 18, because it has a 0. You can use the other one. It's not a problem. I'm going to use the 0, 18. So I'm going to put y minus 18 equals my slope, negative 3/10 times x minus 0. And because I have x minus 0 right here, that's just x. So I have y minus 18 equals negative 3/10 x. And then we're going to add 18. And I get y equals negative 3/10 x plus 18. Before I go and interpret anything, what is my y-intercept? In this equation, what is my y-intercept? In this equation, Holland, what's my y-intercept? Right, so 0, 18. Oops. 0, 18 is the y-intercept. We look at the graph. Is 0, 18 on that graph? So there is a little check to make sure you have the correct answer. Like my y-intercept matches what's on the graph. Okay, we need to interpret the slope and the y-intercept. I'm going to start with the y-intercept just because I was just talking about that. Let's interpret that. That means write in words. So we're going to do the y-intercept. So we look at 0, 18. 0 is the x, 18 is the balance. So when we think about this, Aya, could you help me with this one? What does the 0 in 0, 18, what's the 0 tell me? A little bit louder, I can't hear you at all. So the first number is 0, and the first number is the x values. So we're going to say that we've made 0 payments. If you make 0 payments, you still owe how much money? If we make 0 payments, how much money do we still owe? Warren, how much money do we still owe? If we make 0 payments, I'm talking about this ordered pair right here, $18,000. And thank you for reading the 1,000 part. You guys ever hear how it says thousands of dollars? Like, don't put $18 for a car. We should know better, right? Okay, $18,000. So that's interpreting the y-intercept. Now let's interpret the slope. So when I interpret the slope, I take negative 3/10 and I change it to a decimal, negative 0.3, negative 3/10. I do that so I can talk about that per 1. So the slope is the y's over the x's. So we look at this situation, and my y's is the balance. That's the balance. This is the number of payments. So what does negative 0.3 over 1 interpret to be? Negative means something's decreasing. That's why we need to use words like decreases or going down or less when we're talking about negative. So the balance is decreasing. So now I'm not going to write it decreases by negative 0.3. I'm going to say it decreases, and I'm going to say 0.3, because that means negative. I'm going to say decreases by 0.3, and then to make it even better, I'll put 1,000. Dollars per one payment. So when you talk about the slope is a rate. It needs to have the word per in it, or for every payment. Something that kind of means per. What is $3,000? What is 0.3 of 1,000? Does anybody know? Do you hear me calculate that? I wasn't doing it. What is it? Nina, do you know? A little bit louder, hon. Yeah, it is. Yours is a really muffled one. Okay, so it'd actually be, you could put 300 in there. You don't have to write 0.3,000. You could write $300 if you want. Okay, this interpreting thing would be something that I would grade on my own when I read it. I would never have Canvas grade that for you. Or it would be like a multiple choice. All right, the next one, modeling with mathematics. We've got, and you're on the prom committee, so you got to decide where the prom's going to be if we have prom. Right? Okay. Charge a rental fee plus a fee per student. So there's an initial rental fee plus a fee per student. This table shows different costs for different numbers of students at Lakeside Inn. And then we also have another place called the Sunview Resort that is represented by the equation y equals 10x plus 600. We need to compare these venues. We need to know which venue charges less per student. How much or how many students must attend for the total cost to be the same. So this y equals the Sunview room is y equals 10x plus 600. And if I really want to compare them, I can compare them side by side. For 100 students, the Sunview room would be 10 times 100 plus 600, which is 1,600. If you only have 100 students going to prom, which venue would you want to choose? Based on price alone, come on, guys. Which venue would you choose? Lakeside or Sunview? Lakeside? No? Sunview? No? What are you guys going to choose? Nobody raised their hand. What are you going to choose? Brooke, what are you choosing? What? Lakeside. Right, because it's cheaper. All right, how about 125? 125. We've got 10 times 125 plus 600. Oops. And we're at 1850. Should we still choose Lakeside? But did you see that we're getting closer? How about 150 students? Should we still choose Lakeside? What's this? Oh. So it doesn't matter for this one, does it? So if we have 150 students, we go either way. So what happens at 175 without even knowing the answer? What happens at 175? Do you know? Ariana? It'll be cheaper for what? What's going to be cheaper? Which venue? Sunview, yeah. It'll end up, that one will be the better choice at this point. So let's do 175 times 10 plus 600, and we get 2350. And we compare those, and after 150, we're going to want to go by Sunview room. So it's kind of important to know about how many people you plan on having at the prom for that. Which venue charges less per student? We need to know how much per student. Sunview room, how much do they charge per student? Sunview charges so much per student. Do you hear the word per in there? PER is a rate. What part of the equation is the rate? What part of the equation is the rate? Ariana? The slope. So we look at our slope for Sunview, and it's $10 per student. How about Lakeside? How much do they charge per student? Or we're not given that information. So we need to find that information. We're going to find that information by knowing the slope of Lakeside. So let's find two ordered pairs. I'll just use the first two. And let's do our slope formula. y2 minus y1 over x2 minus x1. So 1,800 minus 1,500 over 125 minus 100. 300 over 25. We get $12 per student. So which venue charges less per student? That would be Sunview. Sunview charges less per student. How many students must attend for the total cost to be the same? We already found that one at 150. You're going to have to do that in your assignment as well. Compare. Underneath here it says, how do we know the table above shows an exact linear relationship? And what you would want to do to find out that it's an exact linear relationship is to check the slope for every pair. I'll just do it in a different color. So let's see, from here to here is 25. From here to here is 25. Here to here is 25. Here to here is 25. So I'm finding y2 minus y1 for every single one of those. Or those are x2 minus x1 for every single one of those. Then I'm going to do y2 minus y1 for all of these. So this would be 300, 300, 300, 300. So does 300 over 25 equal 300 over 25 equal 300 over 25, etc.? Does that all equal the same thing? What if I had a 600 over 50? That would be the same thing. So if the x's aren't counting by the same amount, we can still compare them. What if I had a 1,250 over 175? Would you pull out your calculator? and I get 7.14-ish. So if I have one that doesn't match, then it would not be linear. Now that was an example that was not in our table. So our table was an exact linear equation, but not everything in life is. So to tell if it is exactly linear, you need to find all of those differences and put them on top of each other to see that they all equal the same amount. And then we're just going to skip this last one for time. It's just another example that's similar to this one. I'm going to stop this video, and I'm going to create a new video for the second half of the notes. The second half are all graphing calculator stuff.